Hi guys, let's look at the last exercise of this chapter, which is exercise 22C. Basically a revision exercise, no new concept. So in this question, we need to find the length of AD. So for finding the length of AD, either I need to know CD or I need to know AC. If I'm looking at this small triangle, if I'm looking at this big triangle, then I need to know this angle. Let's try and find this angle. So angle BCA plus angle DCA form a linear pair, which means they should be equal to 180 degree, which means therefore angle BCA would be equal to 180 degree minus 48 degree, which is 132 degree. So we've got this angle as 132 degree. Now I notice that in triangle BCA, AC and BC are given equal, which means it's an isosceles triangle. So let's just write that down. In triangle ABC, BC is equal to AC. This is given. Therefore, triangle ABC is isosceles, which means angle CBA is equal to angle CAB is equal to 180 degree minus 132 degree upon 2, right? So if this is x, this will be divided by 2. Therefore, angle CBA is equal to 180 minus 132, that's 48. 48 degree upon 2 is equal to 24 degree. So this angle is 24 degree. Now I know I have the value of the hypotenuse, reference to angle 24. This is the opposite or the perpendicular. So we'll use sine. So sine 24 degree would be equal to AD upon AB. Sine 24 degree, the value is 0.4067 multiplied with AB, that's 30. It should give me the value of AD. 4067 multiplied with 3, 21, 18 plus 2, 20, that's 2 and 12. How many decimals? 4, but 1 gone, which means 3. So 12.201. Therefore, AD is equal to 12.201 meter. You can leave your answer like this. If you want to round it off, you should round it off to 2 decimal places. My recommendation would be don't round it off unless the question asks for it. Good. Let's look at the next question. The next question that we do is question number 2. Oh, I've written it 3, but this is basically question number 2. So let's look at question number 2. What does question 2 says? AB is a floorboard, PQRS is a cubical box with each edge as 1 meter. So PQ, QR, RS and PS are 1 meter each. Find length of AB. So I need to find length of AB and I can divide it into 2 parts, AP and PB. Basically, I need to find the hypotenuse. I should know either the base or the perpendicular. So if I look at this small triangle PSB, I know for reference angle 60 degree, this is the perpendicular. Now, if since PQ and this is a cubical thing, which means this is parallel to this, which means this angle and this angle will be equal. Yes, these are corresponding angles. So this angle will also be 60 degree. And this triangle, I have the base available if I look at this as the reference angle. So I should be able to get this value. Perfect. Let's start writing. In triangle PBS, we have perpendicular, which means sine 60 degree is equal to PS upon PB. Sine 60 degree is root 3 upon 2. PS is 1 and PB we need to calculate, which means PB will be equal to 2 upon root 3. Let's rationalize this. So this becomes PB is equal to 2 root 3 upon 3 meter. Done. I have the first part of my question available. Let's look at the second triangle. So we'll still need to write, since PQ is parallel to BR, therefore angle PBS is equal to angle APQ. These are corresponding, this is equal to 60 degree, corresponding angles. Good, which means in triangle APQ, This is the this triangle that I'm referring to. I have the base available, which means I will use cos. So cos 60 degree would be equal to PQ upon AP. Cos 60 degree is half. Yes, cos 60 degree is half. So half is equal to PQ, which is 1 upon AP, which means AP is equal to 2 meter. So I have AP as 2 meter and I have PB as 2 root 3 upon 3 meter. Therefore, AB is equal to AP plus BP, which is 2 plus 2 root 3 upon 3 meter. Let's do this multiplication. So this would be 2 into root 3, that's 1732 multiplied by 2, 4, 6, 14, 5. 3 decimals, so 5.464, and 5.464 divided by 3. So 3, 1, 3, that's 2, 4. Why is this 5? This is 1.72 should be 3. So 2, 4, 2, 3, 6, 14, and 2 into 1, 2 plus 1, 3. This is 3.464. So this should be 3 point. Mistake, I'm glad I realized it well in time. This is 3.464. So 3 minus 3, that's 0. Bring down 2, bring down 4, that's again 1, 3, 16, that's 5, 15, and that's 14, that's 12. So this is equal to 2 plus 1.154 meter, which is 3.154 meter. Therefore, AB is equal to 3.154 meter. If you want to round it off, you should round it off to 2 decimal places, which will be 3.15 meter. Good. Let's look at the next question. The next question that we're doing is question number 5. Question number 5 says radius of a circle with center C is 15 centimeter. Okay, so let's just draw a rough diagram. This is a radius of a circle with center C is 15 centimeter. So let this be the center C. Next, chord AB subtends an angle of 131 degree at the center. So if this is the chord AC, it subtends an angle of 131 degree at the center. Done. This is 131 degree. So AC and BC are equal because these are radii of the same circle. Perfect. So we should be able to get something. Using trigonometry, calculate length of AB, okay, and distance of AB from C, which means for that I will have to draw perpendicular from C onto AB, which will give me the distance. Let this point be D. So let's just write that down. Construct CD perpendicular to AB. So we need to find the length of CD and we need to find the length of AB. That's what we need to find. If you remember your 9th standard math where we did the chapter on circles, you would know perpendicular from the center of a circle to a chord bisects it, which means AD will be equal to BD. So let's just write that down. Perpendicular from center of a circle to a chord bisects it. Therefore, AD is equal to BD. Done. Which also means that this is these two triangles ADC and BDC are congruent by side, side, side. Let's write that down. In triangle ADC and triangle BDC, number 3 is AD is equal to BD. This is from 2. Next, number 4, AC is equal to BC. This is radii, double I, not triple I, radii of same circle. And next is CD is equal to CD. This is common side. Therefore, by SSS test, triangle ACD is congruent to triangle BCD. What it also means is angle ACD is equal to angle BCD. This is CPCTC. Now we know the total angle is 131, which means the half of that angle would be 131 upon 2. So let's just write that down. Therefore, angle ACD is equal to angle BCD is equal to 131 degree upon 2, which is equal to 65.5 degree. This can also be written as 65 degree. How many minutes? 30 minutes. Each degree has, not seconds, I have written second, 30 minutes. Perfect. So this is the angle. This angle is 65.5 degree. Good. So now if I look at right triangle ADC, I have this angle available. I need to find for this reference angle, this is opposite or the perpendicular. So in triangle ACD, number 9 would be sine 65.5 degree would be equal to AD upon AC. AC is the radius, which is given equal to 15 centimeter. Perfect. And right, sine 65.5, that's 0.9100 multiplied by AC, which is 15, should give me the length of AD. Let's do this multiplication. So 91 into 15, that's 5, 5 9s are 45, 1 9, 5 6 13. That's how many decimals? 2 decimal. So this is 13.65. Therefore, AD is equal to 13.65 centimeter. Done. We need to calculate the length of AB, which is, this is point number 10, which means AB is equal to 2 times AD, which is 2 into 13.65 centimeter. Let me erase this calculation, so I'll have space for the second part of the question, which means therefore AB will be equal to 2 into 13, that's 26, and 65 into 2, that's 130. So this will be 27.30 centimeter. That's the first part of my answer to part 1. Next, I need to calculate the length of AB from C, which means this time I need to calculate CD. Now I can either use Pythagoras theorem, but they clearly say use trigonometry, which means for this reference angle, CD is the base, which means I will use cos. So then cos 65.5 degree would be equal to CD upon AC. As per the book, cos 65.5 degree is 0.4147 multiplied with AC, that's 15, is equal to CD. Let's do this multiplication. 4147, 15, that's 35, 3, that's 23, 2, 5 and 2, 7, and that's 20. This will be 7414. This is 5, 10, that's 8 plus 4, 12. This is 2 and 6. So 62205, how many decimals? 4. 1, 2, 3, 4. So this is 6.2205. Okay, let me erase this as well. I'll have space to write my final answer. Okay, so therefore CD is equal to 6.2205 centimeter. That's what they wanted. This is answer part 2. Done. Interesting question. Required us to use trigonometry in a circle. Good. Let's look at the next question. The next question that we do is question number 6. Question 6 is, as a point on level ground, the angle of elevation of a vertical tower is such that its tangent is 5 by 12. Let's just draw a rough diagram. So this is my vertical tower. This is the ground. The angle of elevation is such that walking 120, okay, so then we are coming closer to the tower. So this is the original position. This is 90 degree. Let's call this point A. This is point B, and this is point C. Then we are coming closer to the tower, which means we are walking some distance. And this distance that we are walking is 192 meter. Perfect. Now the tangent is 3 by 4. So let the first angle be alpha, let the second angle be beta. Perfect. So as per this, tan alpha is given equal to, tan alpha will be perpendicular upon base, in this case AB upon BC. This is given equal to 5 upon 12. Perfect. And tan beta is given equal to AB upon, let's name this point D. So this is AB upon BD, which is given equal to 3 upon 4. So AB is basically equal to 5x. So AB is 5x and BC is 12x. Perfect. And AB is also equal to 3y because I'm taking a different angle, so I'm taking a different ratio. So in this case, the constant I've taken as y, and BD is equal to 4y. Perfect. I hope you got this point clear. This is AB. From this, AB is equal to 5, but it's not 5, it's a ratio, which means it's 5x. So let AB is equal to 5x, therefore BC is equal to 12x, and let AB is equal to 3y, different variable, and therefore BD is equal to 4y. Now we know that AB and AB are equal, which means 5x and 3y are equal, which means 5x is equal to 3y. Let's write this as 5x minus 3y is equal to 0. Let's give them some numbers so that's easier for us to refer to them again. So this is 3, 4, 5, 6, 7 and 8. So that's my first equation. 5x minus 3y is equal to 0. Next, I have 4y plus 192 is equal to 12x because BC is equal to BC and BC is equal to 12x. Perfect. So number 9 would be 4y plus 192 would be equal to 12x. Anything common? Yes, 4 is common, and let's divide everything by 4. So this would become y plus 4 into 3, 4 into 4, sorry. 4 4s are 16, that's 32, that's 48, so this is 3x. Let's write it in the same form as the first equation, which means 3x minus y is equal to 48. That's my point number 11, and this is equation number 2. So I have two simultaneous equations. Let's try and solve them simultaneously. So I have 5x minus 3y and 3x minus y. So let's multiply the second equation with 3. If I multiply this, I'll get the coefficient of y equal. So this would become 9x minus 3y is equal to 120 and 24. That's 144. And I have 5x minus 3y is equal to 0. Let's subtract. Sign changes. This becomes 0. This is 144. 9 minus 5 is 4. The 4x is equal to 144. X would be 144 upon 4. Therefore, x is equal to 4 into 3, 12. That's 24. So that's 36. So x is equal to 36. We need to find the height of the tower. It is given in meter. So 36 meter, which means therefore AB is equal to height is equal to 5x, which is 5 into 36 meter. That's 150 and 30, 180 meter. Perfect. So the height of the tower is 180 meter. That finishes this video for me. Let me just give you some homework questions. Question number 1, part 1, and question number 4. Thank you so much. Take care. Be safe. I'll see you with the next video.